Good afternoon all. Welcome to the topic, interesting topic. This is in mathematics. So far we discussed the topic in operation research, the linear programming problem. This linear programming problem are used in accounting, purchasing, inventory control, queuing theory. Then more topics are used in this linear programming problem. In this video, we discussed operation research and introduction, overview, linear programming problem and basic definitions, general form, standard form, canonical form and simplex procedure. First of all, we discussed about the operation research. Shortly, we abbreviated OR. The OR means the new study of systematic and scientific approach of the operations of the system. This is called the operation research. The basic idea of operation research, it is the analytical model and analytical problem are solved by OR techniques. The decision problem that is used in the decision making, that is useful in management studies of the organization. But decision making means the problem is deals with the maximized or minimized in the operation research. The general phase of OR. General phase of OR means the problem is given by the real life situation problem. Then the problem is converted into mathematical model. After then solving by OR techniques, the OR techniques problems are implemented in the results into the real life situation. Again, the implementation after the verification, the output of the problem is given in the real life situation result. Next, we are discussed about the linear programming problem. There are two types of the linear programming problem. The first one is maximize problem, such as the maximizing the profit. Then another one minimize the problem, such as minimizing the profit cost. The general form of linear programming problem is as follows. The general form means it is a maximized or minimized of Z equation. A maximized or minimized of the Z equation is equal to that objective cost C1 and X1 are the variables, X1, X2, etc. Xn are the variables and C1, C2, etc. Cn are the cost. So here given the objective function maximize or minimize of Z equation is equal to C1, X1 plus C2, X2 plus etc. plus Cn, Xn. And next, subject to the constraints, here given STC, that is the A11, A12, etc. A1n are the subject to the constants, and that is the left hand side constraints. The right hand side constants are B1, B2, etc. Bm. That is, we have to rewrite A11 x1 plus A12 x2 plus etc. A1 and xn less than or equal or greater than or equal to B1. Then second equation up to the last equation says that am1 x1 plus am2 x2 plus etc. amn xn less than or equal to greater than or equal to bm. And non-negativity constraints x1, x2, etc. xn greater than or equal to 0. Generally, the general form of the linear programming problem, it is basically step 1 is the objective function, step 2 is the subject to the constraints, the third one non-negativity restrictions. Next, we have to define canonical structure of the linear programming problem. The first canonical structure means the objective function should be the maximization type and subject to the constraints all the constraints should be written in less than or equal to type. Here, maximize Z equal to C1 x1 plus C2 x2 plus etc. Cn xn, and subject to the constraints we have to write in the left hand side and right hand side, and the inequality is related to the less than or equal to type. Therefore, here the equation A11 x1 plus A12 etc. plus A1n xn less than or equal to B1. Then second equation up to the last equation we stand for the return in this general form, where x1, x2, etc. xn are greater than or equal to 0. This is the non-negativity restrictions. Next, define standard form of LPP. Standard structure we have to return as STD structure of LPP. The objective function should be maximized type and subject to the constraints all the equations are expressed as the equalities and non-negativity restrictions are greater than or equal to 0. Therefore, here objective function are maximized is that equal to C1 x1 plus C2 x2 plus etc. Cn xn, and subject to the constraints are written as first equation, then second equation up to last equations are equality type. Then last third step is non-negativity restrictions are defined as x1 greater than or equal to 0, x2 greater than or equal to 0 up to etc. xn greater than or equal to 0. Next, we define characteristics form. The characteristic form are given in general form, standard form, canonical form. In general form of the characteristics means the objective function should be maximized or minimized. Subject to the constraints should be less than or equal to or greater than or equal to type. And the non-negative variables are all the non-negative restrictions are should be positive. That is the general form in the LPP. In the standard form in the LPP means objective function should be maximized type only and subject to the constraints are expressed in the equations only, and right hand side constant in the subject to the constraints all are positive and non-negativity variables all are positive. That is the standard form of the characteristics. Next, the canonical form of the characteristics, that means the objective here also should be maximization type and subject to the constraints here only given in less than or equal to type, and all the variables are should be greater than or equal to type. That means it is a non-negative, that is the positive values. Next, we define a basic definitions. Here the basic definition one by one we recall that the basic variables, slack variables, surplus variables, artificial variables. The first one is basic variable. The basic variables means we are taking the decision variable, it is called the basic variables x1, x2, etc. xn, that is the basic variables. Next is slack variable. In the slack variable we are introducing in the subject to the constraints only. If the problem is subject to the constraints are given in less than or equal to type, we have to convert it into equality type. We are introducing the left hand side by adding a slack variable, that is we have to taking the notation SI. For example, 3x1 plus 4x2 is less than or equal to 5. Here, less than or equal to type is converted into equality type. Therefore, here introducing a slack variable in the left hand side. So, here the equation implies that 3x1 plus 4x2 plus s1 is equal to 5. That is the slack variable problem. In surplus variable means the same manner as in the slack variable problem. In the surplus variable, we have to define as left hand side also greater than or equal to type converted into equality type. So here subtracting the surplus variable and adding the artificial variable is equal to constant in the subject to the constraint. Therefore, here the equations, for example, 2x1 plus x2 is greater than or equal to 5. So here the problem is defined as 2x1 plus x2 minus surplus variable plus artificial variable is equal to 5. That is, we are introducing the surplus variable and artificial variable. Next, to discuss simplex procedure. The simplex procedure only we have to define in the standard form. The first step, check the objective function. The objective function should be maximization type only. The problem suppose given in minimization type means the problem is converted into maximization type. But suppose the given problem minimization means we have to multiply by -1 on both sides. We get the problem is converted into maximization type. That is the formula for minimum of Z equation. Given the problem in minimum of Z equation, we are converted into maximum problem. Therefore, the maximum of Z star is equal to minus minimum of minus Z. That is the conversion of the minimum problem converted into maximum problem. Next step, subject to the constraints. Subject to the constraints only we are defined the less than or equal to type only. The third step, all the right hand side constants are expressed as the positive values, that is non-negative values only. Next is simplex table. Generally the simplex table, the first the row headings means the first column define objective function coefficient. The second column are the given variables. The third column are defined as the right hand side constant. Next, the basic variables x1, x2, x3, etc. and introducing variable s1, s2, etc. variables. The last column here defining the ratio. Ratio means that is ratio is equal to the right hand side constant xb divided by and pivotal element. Entering element. These entering element pivot defined as the ratio. The ratio means minimum of xb divided by entering variable. That is here defining in the ratio column. Next here, define last row. Last row is the net evaluation row, Zj minus Cj row. In this Zj minus Cj row, that is we called the net evaluation. Here all values are positive means the problem attained optimality. Otherwise, go to the next step. In the next step, we select the most negative in the net evaluation column. That is called the pivot column. In the same procedure, we have to calculate ratio. We have to define the formula for ratio, minimum ratio. In this minimum ratio, that is the leaving row, that is called the pivotal row. In the pivotal column, that is enter the table. Pivotal row is the leaving table. In pivotal column and pivotal row, intersecting element is called the pivotal element or key element. Next, we go to the next iteration table using the calculation of the formula. We have to define the all other element. Again, we have to repeat the same procedure for this formula until all the net evaluation values are non-negative. But next, finally, we have to represent the optimality solution. This is the simplex procedure. Generally, we have to define all the problems are discussed about this manner. We have to define the simplex procedure. Next one, problem express the linear programming problem in standard form. Here the problem is converted into standard form. The given problem maximum is equal to 7x1 plus 5x2 subject to the constraint 2x1 plus 3x2 less than or equal to 20, 3x1 plus x2 greater than or equal to 10 and x1 comma x2 greater than or equal to 0. That is the non-negative problem. Here the problem is converted into standard form. The problem objective function is maximization type. Therefore, objective the same, we have to return an objective function maximum is equal to 7x1 plus 5x2. In the subject to the constraints are given the inequality less than or equal to type is the first equation, greater than or equal to type in the second equation. Therefore, we are converted into standard form means we have to express as the equality. But less than or equal to type means we have to introducing slack variable in the left hand side. Greater than or equal to type means we have to introducing surplus variable in the left hand side. So here in the first equation introducing slack variable, the second equation introducing surplus variable. Therefore, the equation gives 2x1 plus 3x2 plus s1 is equal to 20. The second equation 3x1 plus x2 minus s2 is equal to 10. That is the answer. And all other variables are greater than or equal to 0. Here the variables given problem variable x1, x2, introducing variable s1, s2. Therefore, the non-negative variables are x1, x2, s1, s2. All variables are greater than or equal to 0. That is the completion of the standard form. On the whole, we have to learn about what is operation research, linear programming problem, and basic definition, surplus variable, slack variable, basic variable, artificial variables are defined, and general form, standard form, canonical form of the linear programming problem, simplex procedure. Thank you for watching this video.